You've probably heard that the flapping of a butterfly's wings can cause a hurricane thousands of miles away. But can this really happen? It's hard to tell. Okay, maybe a butterfly won't decide whether a hurricane will form or not, but that flapping could affect which location the eye of the storm will land, or if it's a Category 3 or 4. We don't have time machines yet, so we don't know if the butterfly has any effect at all. There are so many different factors that could affect the hurricane. Maybe that butterfly's alright, but what about that ladybug over there? Okay. So we know we can't predict everything that happens in the world. Or can we? What if there's actually a way to predict something that's unpredictable? Welcome to the world of chaos theory. Chaos theory is an explanation for something that just doesn't make sense. It basically states that there are too many factors in a situation to be able to come up with a consistent formula to predict what will happen, even if you observe the same thing over and over again. No matter how long you study that butterfly, you won't be able to predict where the hurricane is going to land, let alone what flower it's going to fly to. Back in the 1950s and 60s, a scientist and mathematician named Edward Lorenz was creating a mathematical computer simulation to predict the weather. Lorenz soon realized that his model was not as accurate as he had hoped, being too predictable for something like weather. No storm repeats itself in the exact same way, or will come at the same time, even if all the conditions are the same. He concluded that there must be many tiny factors involved that also had an effect on the weather. It was here that Lorenz started to explore the idea of chaos theory, that there were too many factors to truly make accurate predictions about the universe. He also called chaos theory the butterfly effect. Recently, scientists have come up with a formula for chaos theory. The formula is plotted on a three-dimensional graph with an x, y, and z axis. Each expression is a derivative, or equation for slope, on each axis. This is important because more than one equation can have the same slope, and thus yield the same results. When you plot the three equations together, you get a nice, even shape, sort of like a figure 8 that varies at each rotation. The shape is known as the Lorenz attractor, and is sometimes thought to look like a butterfly. Chaos theory has led to a new method of making predictions called empirical dynamic modeling. The idea behind it is using only raw data and not making any assumptions about patterns. This encourages researchers to be more open to other factors and ideas, and have actually been more accurate about predicting things like wildlife populations, environmental effects, and others.